Hello, students. Welcome back to some distance learning. We're going to pick up with something new. We're not going to follow, we're not going to take a test on the content we were working on before break. We'll just start fresh and move forward. So this unit is Unit 10, and it is on what we call trigonometry. All right, so trigonometry. We're actually working with trigonometric functions. So what's really cool about these functions is that there's three major ones. We'll focus in, there's six total, but we're going to focus in on the three major ones. The first one is called sine. The second, the first one is called sine. The second one is called cosine. And the third one is called tangent. And what they represent is the relationship between angle measures in the triangle and the side lengths of a triangle. So sine, cosine, and tangent, all three of them have some representation. Now they're abbreviated like this: sine, cosine, and tangent. So when I use three letters, which I'll continue to use after this moment in time, I'm talking about sine, cosine, and tangent, even though it is abbreviated. It's not pronounced sin. Do not say sin. It's sine because there's an E there. We just don't see the E all the time. Cosine and tangent. All right. Now, what are these? Well, they're a relationship between the sides and the angles. So, for instance, sine of any angle in a triangle, that's not the 90-degree one, is equal to the opposite side of a triangle over the adjacent side of a triangle. The cosine of an angle is equal to the adjacent, I'm so sorry, I messed this up, opposite over hypotenuse. The cosine is equal to the adjacent side over the hypotenuse side. And the tangent of an angle is equal to the opposite side. This is the one I did at the top because normally I do tangent first, but I started with sine. So this one is opposite over the adjacent side. So it's truly just a relationship. This angle measure, whatever this angle measure is right here, it's equivalent in relationship of sine to an opposite over hypotenuse side. The cosine angle is equal to this relationship, and then this one, tangent of this angle, is equal to the opposite over the adjacent side. A lot of the times, if you're confused or you forget what it is, there's an acronym called SOHCAHTOA, which when put together looks like this: SOHCAHTOA. I'm going to use a capital T. SOHCAHTOA. And what it shows is that sine S is equal to OH, which is opposite over hypotenuse. And then cosine C is equal to the adjacent side over the hypotenuse side. And then tangent T, so I use capital T, is equal to opposite over adjacent side. So this acronym, as long as you memorize the acronym, you can use it all the time. You just can write it at the top of your paper and then do the workout for it. All right. So I'm going to leave that in our notes here. Let me make a little adjustment here. Let me add a page. Let me see if I can add a page. Add page. There we go. Because I want to be able to put just the notes. Why is it not letting? Here we go. All right, so I'm going to just copy these notes over to the top so that we have them separate from the questions that we're answering. Okay, now let's talk about a triangle, because in a right, it has to be a right triangle. All right, so here, let's draw a right triangle out. And we always have a right angle. We can only use trig. We can only use trig with a right triangle. Only use trig. Well, that's not true, but we can only use trig functions in this respect. With a right triangle. Now, there are other things like the law of sines, the law of cosines, that allow us to do other things. We're not going to get into those. So right now, I just want to make sure that all the ones we focus in on are right triangles. So we can never use this angle right here. We can never use the right angle, but we can use any of the other ones. So A, B, and C. Those are my angles, A, angle B, angle C. I'll change the color of them. Oh, it looks like I didn't do a good job with this. Let's try this again. Okay. So if I want to know what the sine of A is, the sine of A, let me also put variables on here, X, Y, and Z. So those are side lengths. So the sine here of angle A is equal to the opposite side over the hypotenuse. So let's look at A. The opposite side here is side X. Okay? Because all the way over here, and the hypotenuse is always this one. It's opposite the right angle. So this would be X over Z. This one being opposite to angle A, and then Y being adjacent to angle A. So there are always two adjacent sides. There's the ones that make the angle up. See how angle A is being made up of two sides? The question is, which one is adjacent and which one is adjacent but the longest, right? The longest is the hypotenuse. So here we have adjacent being Y and hypotenuse being Z. So the sine of A is equal to X over Z. But let's talk about what cosine of A would be. Well, cosine of A, cosine of A, my apologies, cosine of angle A, the same angle, but the cosine, well, that's adjacent Y over Z, because adjacent over hypotenuse. And then lastly, we could write tangent of angle A, which is going to be the opposite X over the adjacent Y. So these are just three of the possibilities that we have when doing sine, cosine, and tangent. Those are the only notes I have for you. We just need to we need to focus in on what angle we're talking about, okay? We always have to focus on what the hypotenuse is, because we can't use that as the opposite or the adjacent side. That one you always want to label first. You just want to get that one out of the way. Okay, so always get the hypotenuse out of the way. Label that. And then look at what angle it's talking about, and then try to go from there. Is it opposite over hypotenuse? Is it opposite over adjacent? Is it adjacent over hypotenuse? And that's going to tell you how you're going to want to set that up. So let's do a couple examples from IXL. Again, we are in the Algebra 1. I forget if I said this, but we're in Algebra 1 IXL. We're going to do HH1 through HH6, okay? So Algebra 1, HH1 through HH6. Now, we're only doing 2 lessons a week. So that means that I made enough for 3 weeks plus the week of our test. I don't know how long we're going to be out for, so I just wanted to prepare. So only HH1 and HH2 are due this week. I'll make another video for HH2. All right. So this first question is going to be, what is the sine of x? Okay. So the sine of x is going to be the opposite over the hypotenuse. The issue is, whoop, I don't have my hypotenuse. We're missing that one. So let's just do a little bit of algebra to find the hypotenuse. We're going to do the Pythagorean theorem. So 5 squared plus 12 squared equals h squared. We don't know what the hypotenuse is. 25 plus 144 equals 160 equals h squared. 169 equals h squared. So the square root of 169 equals the square root of h squared. So h equals 13. You can use your Google Chromebook. You don't need on your Google Chromebook you have a calculator, but you can also type in calculator at the top of Google Chrome itself, and you can do all the algebra that you need. So this one is 13. All right. And so now that we have all three values, sometimes you won't need all three, but I'm going to label this one the hypotenuse. And now, which one is the opposite and which one is the adjacent side? Well, let's take a look. Our focus is on angle X, so it's about this angle right here. So the opposite side is 12 to X, and then 13 is the hypotenuse. So the answer here is going to be 12 divided by 13, but I'm surprised it wants it as a decimal, but we're just going to do that algebra. We're going to do that calculation, and we get 12 over 13 is approximately 0.9230769. It wants it rounded to the nearest hundredth, so it's going to be 0.92. And we're done. You would submit that answer, and that's it. You're just writing it as pretty much, this lesson's about writing a fraction and then turning into a decimal rounded to the nearest hundredth. Okay, the next one, cosine. Well, cosine of my angle is equal to the adjacent over the hypotenuse. So cosine of my angle is equal to adjacent. Oh, I might be missing a piece. Yeah, it looks like I need to do some algebra. So I have to do the Pythagorean theorem to find my missing piece. So we're going to call that x. So so 35 squared plus x squared equals 37 squared. And I do 35 times 35. I get 1225. And I'm going to do 37 times 37, which is 1369. And I'm going to take away 1225. So I get x squared equals 144, and this should stand out to you. You guys know what the square root of 144 is. It's 12. So this missing piece here is 12. So, whoops. Oops, again, I did it. I don't like this update. It doesn't let me pull. Nope. I want to pull just my numbers, and I want to move my numbers. There we go. I got it. It finally let me. X is 12. Okay. This one is my hypotenuse. Not sure what it's doing. This one's my hypotenuse because opposite the right angle. And then when I'm talking about angle F, that one's this one right here. So I want to know which one is the adjacent side over the hypotenuse side. Again, I'm not interested in the opposite over here, just the adjacent side. And it's all about the angle. If we used angle G, this would have been the opposite side. This would have been the adjacent side. It's all about the angle you're picking. So this is a cosine of F, so that's 12 divided by 37. Now in the calculator, we're going to do 12 divided by 37, and we're going to get about 0.32432, which is about 0.32 when rounded to the nearest decimal. Nearest 100, sorry, as a decimal. All right, tangent now. Tangent, we have tangent. Don't forget, what is the acronym? SOHCAHTOA. So tangent of my angle is equal to the opposite side over the adjacent side. Oh, look at this one. It has all my values. I don't have to use the Pythagorean theorem. This is awesome. I probably went in a different order. So they're going to get more difficult. It appears I started with more difficult ones. So sometimes you'll have everything you need. So I want to label my hypotenuse right away. I always want to do that. Okay, what's the angle? It's angle R. So angle R is right there. So let's put a tick mark in. That's angle R. Whoops. So it's the tangent. So that's the opposite over the adjacent. Remember, opposite, if R exists, opposite it is what doesn't make up R at all. Look how this side doesn't go anywhere near or touch R. That's how you can tell what opposite is. Adjacent both make up R. Check that out. They're both adjacent. Remember, one of them is a special adjacent called the hypotenuse. All right. So, looks like we have opposite over adjacent. So the tangent of my angle is going to be, whoops, I don't know what I just did. Okay, didn't do much. So the tangent of my angle is equal to the opposite, 72, over the adjacent, 65. So 72 over 65 is approximately 1.1076923. So rounded to the nearest hundredth is 1.1211. The 0 rounds up to another 1 because 7 rounds the 0 up to a 1. So 1.11 would be the answer for this one. All right. I got one more for you. This is kind of like the trickiest one because this has radicals in it, but we still need to find, we're going to have to find this side. We don't know what this side is, right? So I'm going to call it x. It equals something, I'm not sure, but I do know that leg squared plus leg squared equals hypotenuse squared. So I have leg squared, so x squared, plus the square root of 39 squared equals, and I'm going to label my hypotenuse, because I should do that always right from the beginning before I even start the problem. So the square root of 91 squared. All right, so x squared plus 39. Remember, the square root square, these are inverse operations. They wipe each other out because you're squaring the square root. It's kind of like multiplying a division, right? You're gonna wipe it out. You're also gonna wipe out this one. So now you just work from there. 39, take away 39. So I think it's 56. Let's see, 91 minus 39. 52, sorry. So x squared equals 52. Now you find the square root of x squared. You find the square root of 52. Again, it's going to wipe each other out. That's why I'm doing this. So x equals the square root of 52. I'm going to write that in right here. And now we're ready to actually find the tangent. Now we're fully prepared to find the tangent of angle J. Angle J is equal to the opposite over the adjacent. So tangent of my angle equals opposite side over the adjacent side. So the tangent of my angle J equals the opposite side, square root of 52 over the adjacent side. Remember, two adjacent sides. One of them is hypotenuse, so over the square root of 39. All right, this approximately equals, let me type this into a calculator. This one might be difficult. Be careful. Use parentheses and whatnot. Square root of 52 divided by 39 square root, and we get approximately 1.1547005. To me, if we're rounding to the nearest hundredth, looks like it drops off to 1.15. All right, so those are the notes. I'll post these in Google Classroom. You'll have them to look at. You have pretty much everything you need to answer. I excel. Remember in Algebra 1, Algebra 1, HH1, which is trig ratios, sine, cosine, and tangent. Okay? So you just want to fill in those ratios. Oh, I can answer this one. It was what, 5 over 13? Yeah. No, I'll leave it to be. But yeah, you have everything you need for HH1. All right. I'll do another video for HH2 and then so on and so forth. Okay, good luck.